Okay, everybody. So welcome to this webinar presented by Human Signal, which is an introduction to Adala, the Autonomous Data Labeling Agent Framework. My name is Chris Hodge, and I'm the head of community for the Label Studio community here at Human Signal, also helping out with the Adala community. And I'll be joined today with Michael Maluk, who is the CEO and one of the founders of Human Signal, and also one of the creators of the open source Label Studio project, as well as Nikolai Lyubimov, who is another one of the authors of Label Studio, the inventor of Adala, and the CTO at Human Signal. With that, so with those introductions, let's get started. For our agenda today, we're first going to talk a little bit about foundation models and set the stage for why agents are important and why Adala addresses some of the issues that large language models themselves present by talking about foundation models and the paradox of data. From there, we'll move into the dawn of agents, setting the stage for agents and how they work, a brief introduction to that. And then finally, we'll introduce Adala and close with a demo of Adala, a live demo, and some questions about it. So to begin, let's talk about foundation models and the paradox of data. So after the last year with the release of ChatGPT, we've seen large language models and foundation models explode into the public consciousness. And these models were largely enabled by using tremendous amounts of data that were coupled with unsupervised learning. And so we're talking about millions to billions of data points, millions to billions of parameters that were tuned by them. And what you wind up with is a librarian who has speed read every single book in the library and can return the knowledge they've learned on demand. It's not always perfect, but it's frequently impressive. And these models have been around for a long time, but they really didn't really capture the public imagination. And part of that was because we hadn't quite yet incorporated very strong human feedback into building these models. And so when you build an LLM in an unsupervised way, there's a real danger of inaccurate or harmful information. And so tools like reinforcement learning from human feedback provided a necessary step to make the models safer and more reliable. But this came back to the idea of requiring a tremendous amount of human insight and data labeling to evaluate and fine-tune the model performance. And then we also have the notion that these models, because they take so much data, you have to do a huge amount of data collection, and they're frequently limited by the knowledge they have, and they can be pinned in time. And this leads us to a kind of paradox of data, where we have these modern models that require a massive amount of data and are frequently more than can possibly be labeled. Unsupervised learning is inexpensive in that way because you don't have to do the labeling, and powerful. But with the best models using a vast amount of data, and that data can be false, biased, or harmful. But we also know that data reviewed by human labelers remains the gold standard and a ground truth for developing and training models. And without human labeled data, actually a lot of these models wouldn't be as effective as they are. Human annotators are expensive, with the best operations assigning multiple reviews for each data point. And so this kind of leads us to this data paradox of where the most powerful models need a lot of data that haven't been reviewed by humans, but they also need to have human oversight to make them effective. And this kind of highlights the need for an efficient, automated solution for gathering data and labeling data that can be guided by human feedback. And this leads us to the idea of agents. Now, agents can be considered dynamic problem solvers, and they've been around for a long time within the machine learning and computer science space. And they have the potential to assist human annotators by providing predictions to almost any task by processing data, highlighting areas that need attention, and even suggesting possible labels based on patterns they've recognized from previous data. Now, you might be asking yourself how these are different from some sort of active learning process. Agents in this context have some distinctions by being powered by LLMs as a kind of a new compute primitive and general knowledge repository, but they can also be self-learning and have the ability to perform tasks continuously within a production environment. Now, reliability is mission critical for being able to, for agents to be able to work. Agents combine knowledge from outputs in LLMs and action on them in production systems. Thus, since they're working in production, their reliability, they need to be reliable and need to correctly and consistently perform operations. But when you merge the power of this automation with the precision of human offsite, you get a really nice and balanced solution. And so for the example that we're going to be used going forward, we're going to guide agent behavior through human feedback and ground truth data. We're going to set parameters to define an operational environment to make sure that agents are behaving within some sort of parameters. And we're going to ensure predictions that are within defined and bound, that are kind of within this defined and bounded range through constraint generation. So with this, let's take a quick look at a generalized agent workflow. You have a user who is interacting with the agent and typically is asking the agent to perform some sort of action or answer some sort of question. The agent will pass that along to the LLM backend, which the LLM will then, mediated through the agent, access a number of different tools that it can use to accomplish a task. And so if you imagine that if you just ask like ChatGPT, like, what's the weather in London? ChatGPT is going to go, I don't know. But by using a tool set that's plugged into the LLM through an agent and guiding the agent on how to use that tool, it can maybe go access the weather service and say, oh, it's going to be 50 degrees and rainy. The tool has passed these observations back to the LLMs. This goes through some sort of feedback loop where this can be refined, and the LLM can refine its behavior. And we can also refine the prompts to the LLM to improve the outputs that it's finally delivering to the user. And so with this high-level overview of how agents work, I'm going to now turn it over to Michael, who is going to introduce Adala, an autonomous data labeling agent framework.
Thank you, Chris. Yeah, so I think we can go to the next slide where I'll speak a little bit about the features that we were thinking about as a kind of guiding stone and the foundational ones when we were designing the Adala agent. The first one that Chris alluded to previously is this reliability feature. Within the data processing tasks, especially if you're working on something that is mission critical, you want the agent to be as reliable as possible, producing the consistent and non-ambiguous results when dealing with your data. Nobody likes to receive the predictions with errors. And one of the key things that we were focusing on initially early on was how do we make the agents reliable? And one part of this reliability is what we call a controllable output. Right now, if you interact with other agents frameworks or with GPT models directly, you may get the outputs that can vary, and because of it, it's sometimes really hard to implement those models into your production applications. And controlling this output was another kind of built-in feature of Adala framework. Then our focus on the data processing tasks, we have some experience with labeling and building the tools to process the data already. And we want to build an agent that can focus on data processing tasks that go beyond just labeling and focus on other parts of how the data can be either generated or analyzed. The autonomous learning, how do we build an agent that can continuously learn from the environment, and you can put in your custom logic when that needs to happen, or you can let the agent decide on when it's a time to actually interact with the environment and learn from it. And flexible and extensible runtime. So obviously, I'll speak a little bit about what a runtime is within the Adala framework, but in its essence, it's the GPT model that powers the entire execution of the agent code. And we started with the support for OpenAI, but over time, we will build support for other GPT models as well. And easily customizable. it's open source product. We're big believers in the open source, and we were building that day one with an expectation that people will adopt, contribute. They will be able to extend, build your own versions of the agents or skills within the agent, and we welcome everyone to participate into our open source repository. Okay, and now a little bit, there are two slides, how the agent gets trained and how the agent code gets executed. So this is a training step, and I will introduce the core concept of what the agent consists of. So on the left, there is a concept of environment. On the, I guess this is a center, it's the Adala agent with a skill, with a single skill. And at the bottom, it's the infrastructure layer that powers execution of the agent. And at the infrastructure layer, there are two components, the runtime and the memory. The way we think about the agent is that agent can have the data that it is using this data to train on. And the agent can use the environment to continuously validate the predictions that the agent is making. That can be happening during the training step of the agent when the agent is trying to train the skill, as well as during the execution of the skill. So the agent can decide that, hey, this is I am applying the skill to this new unseen data. My confidence is very low, therefore I can ask the environment to produce the ground truth validation for that. And the concept of the environment, it's very generic. So you can think about the environment as something that just stores your ground truth data, and this is it. And this is this example on the left. But you can think about where else the validation can come from the environment. One example could be that you can send a message using the Twilio and get back the results. And that would be a validation that environment contributes back into the agent. So it could be an email, anywhere where you can collect the human feedback for that validation, or it doesn't need to be even necessarily coming from the human. Maybe there is external database where you store all the ground truth values. Environment is a concept that can interact with those external knowledge sources and feedback providers and capture them back into the agent so the agent can validate if it's learning into the right direction. And within the agent, this is an example of the classification scale. So there are multiple steps there. So we start with an initial classification instruction. We execute that instruction along with a task that we are trying to classify on the runtime. We get back the results. Again, this result is at that point controllable. So if you predefine your classes for the classification, you would get the results that is within those classes. And this is where you get the classification prediction. And then you can validate that classification prediction. And again, this validation step happens within the environment. And environment tells you, hey, this is actually correct or incorrect. And if it's incorrect, then the Adala agent will analyze why it is incorrect and try to get the experience out of it. This experience can further be stored within the memory. And then there is the refinement step. How do we, based on that experience that we gain, we refine the instruction in such a way that it applies and produces the right class? And we continuously iterate on that and run this loop before there is no more items within the environment from which we can continuously learn. And at that step, you have the agent with a skill that is trained. And we can go to the next slide where we'll show the execution of the trained skill. So in this slide, one thing that is changing, as you can see within the agent, we now have not a single skill, but multiple skills. And in general, the way that Adala agent works, you can have as many skills as you want. You can have different sets of skills. You can group them differently. So basically, you're able to decompose more complicated tasks into a set of a set of simple steps that can be executed linearly, one after another. And within the skill execution, you have the input on the left, which can be the data frames or unstructured data if you're working with something like images. And on the right, there is an output. So in here, we're, again, just classifying the input into two classes, subjective, objective. And on the right, you can see what's this, what are the scores for those two classes. Again, the notion of the runtime here is the LLM that is capable of executing the skills code. Right now, we support only OpenAI, but we'll be looking to add more different runtimes with the next iterations. And within the environment here, you can see that we're being more, we kind of expanded on this idea that, hey, you can get this validation and ground truth from either the external knowledge sources by interacting with things like Slack, emails, phone calls, or you can use the labeling tools that are really well positioned to produce that ground truth data back into your environment and help validate the agents and therefore help it learn better. And I think within the next slide, we're going into the demo to show you what it looks like in as the actual implementation.
Great. Okay. I will run the demo of the Adala framework for you. Just let me quickly share my screen. Okay. Okay, are you able to see my screen with the browser?
Yes, this looks good.
Cool. Okay, so first, I just quickly, like the demo will be structured around the use case that we found kind of useful for different scenarios. And I will quickly describe what exactly we want to achieve and demonstrating the power of Adala here. So as you know, Label Studio, there is a framework that allows you to annotate the data based on your particular needs, and it is highly customizable. So, which means that you can define whatever your task is, and having this task, you can structure the output, desired output, and annotate the given inputs. So, as I just shown you. But the Label Studio is not the core of the demo. So what I want to give you to kind of to understand the problem space is that in order to annotate the data in Label Studio, you require some sort of the pre-annotation. Most of the time, you require the pre-annotations, which means that if you have the model, for example, that can recognize the named entity from the text, you better use this model prior to start the labeling process so that it can speed up your labeling process, and your annotators will not be spending time on annotating the whole text, but they will just review the model answers and then accept the model answers based on wherever they are quality or not. And this is greatly reduce the annotation time, hence improve the effectiveness of data set creation. And there are available many different models in the space that allows you to speed up some pre-annotations work, or that provides the inference out of the box there, and for many diverse set of the tasks. For example, summarizations, translations, and so on and so forth. For the example I just shown you, there exists the token classification problem and corresponding transformers models that are available, for example, on Hugging Face, that you can quickly deploy right in the Hugging Face and use for free as API provider. So, for example, very popular model is the BERT-based NER model that's once deployed, and you can do it for free if you have the Hugging Face account. You can consume the inference outputs from this API. And that's cool because that's something that you might want to connect to the Label Studio to provide the initial inference. But there is a slight problem. So we don't know upfront the format that the API give us when it's being deployed, which means that we can't just go and connect the outputs from these inference endpoints to the Label Studio, so the Label Studio understands this format. So you may require some tedious process of collecting all the data, then converting this data from one format to another format, which is definitely something you want to avoid. What I want to show you today is how you can use the Adala to do this automatic format conversion that gives this ability that performs actually the conversion without you directly being involved into writing the scripts that converts one format to another format. So let's jump into the demo and let's demonstrate everything step by step. So we install Adala in the space, and just to recap, Adala is open source framework that is distributed as a pip package. So you can go on the Adala page and you can find the installation guides, and you can quickly install the Adala on your machine. So once you have this Adala installed, only one thing that we need to bear in mind is, since as being said, we use the OpenAI, so you may use your OpenAI access key that you can get on OpenAI platform, as well as Hugging Face token that allows you to connect to the inference API for free. So we set this in our environment, and we can try to reach the Hugging Face inference endpoints to actually pre-annotate to predict some of the tasks. So let's say that our task is named entity recognizer that extracts some named entity from the given text. So let's quickly run it. Cool. So here are our outputs for from the inference Hugging Face inference API. As you may see, these are the outputs structured as a JSON format. But if we go into what Label Studio understands the format, you can find completely different thing. And actually, whatever the downstream application that needs to consume this task you may find, most likely it will not going to support exactly the formats that you want to connect to, which gives you again the problem of creating the middleware that's convert one format to another format. But let's try to teach our Adala to do this automatic conversion on the fly without anything involved on the coding level. So how we can do this? Again, like we expect, for example, getting the first row where we have the outputs and the inputs provided to the model. We expect that our agent can produce the formats that is understandable by Label Studio. And we can describe it just by one example, like getting the example that we see is the input produced by Hugging Face API. We expect our agent produce the similar JSON, but different structure, different schema of the JSON that is now should be understood by Label Studio. So let's try to compose our agents step by step. And again, we highlighted the architecture components, but I give you the idea how they look in the code level. So we define our agent. This is our generic component, generic instance that will run everything and will be trainable based on whatever feedback we provide. There is the environment. The environment actually is the thing where you can provide the feedback to the agents, meaning like the human feedback. So you do the sort of the supervision for your agents and help them to improve over time. So for the environments in this demonstration, we will be using the Discord channel so that agent can connect to our Discord. And every time it needs for supervision or for help from the human annotator, from human reviewer, it will send the data. It will send the data to the Discord channel so we can provide the feedback right away. The agent skill is exactly what we expect the agent will be doing. And one of the core idea of Adala is that you can not only teach agent one skill, but you can compose different skills together so the agent can operate on some particular pipeline, let's say pipeline, or the sequence of the skill, or even like the interdependent skill that's by producing one task, it can consume another task. So you can think of it as the advanced chain of thought for LLMs that allows you to connect things together and enhance the performance of the agent. And we use the runtime, which is OpenAI runtime for now. So let's first create our environment. And again, this is an environment that connects to the API that proxy to the Discord bot. So essentially, it's just the Discord bots running behind. And we also have we can also specify the data stream for this environment, which means the data stream for us is our initial data set, again, without any ground truth data provided, which we'll be creating on the fly. We define the skill, and the skill can be defined as without any sophisticated instructions. For now, we just can give, okay, just convert the API JSON format without any guidance about what's the format, what's the target format is. You can actually even leave this as completely no instructions, so empty instructions, because we will be learning the instructions on the fly with Adala. And we define the runtime, which is OpenAI GPT model. So let's compose our agent together. As you see, the agent instance is defined, so it instructs agent to be connected to the web environment, to use the skill with the convert API format we provide as the arbitrary name. It used API runtime, and yeah, so now we can run the agent. And running the agent, as Michael showed in the last slides of architecture, is essentially when no learning is involved. So you essentially just get your initial data set and produce the output. As you can see, without any instructions, or having just very simple naive instruction provided at the beginning, the agent produces the JSON format that's essentially almost the same JSON formats that it was given at the beginning. Again, this is not what we expect. What we expect is the Label Studio JSON formats that will be understood and can be uploaded directly to the Label Studio, so we can see the result of the inference endpoint. So let's try to teach our agent to produce this format. In order to start learning process, the only one command should be involved with is the agent learn. And the input to this command is like the time until we wait for feedback in the provided environment, and the number of the examples we need to annotate. In this case, we will be fixed with just one example, but you can define this as like 10 or 100 examples, depending on the quality of the task, the quality of the data, and the quality of agents, and the complexity of the task you can have. So again, let's grab this annotation process. Let's grab this target task that we need to provide as a feedback. Let's start our agent. So as you can see now on the right screen of Discord, the agent requests for the feedback for this payload, which is the input, and the current prediction state, which is the output. In order to provide feedback, we just reply in a channel about the expected outputs that the agent should produce instead of what it produces, what it is producing right now. So once we get the annotation done, the training process starts, and agent learn what it expects, and now it produces something which looks closer to what we expect. So if we double check that, I think it's should be compatible to the Label Studio. Now we accept this result, and that will, since we just have one example to be provided as a feedback, the agent learned it perfectly, and we can assume that the process is completed. So let's rerun our agent again. So applying the new learned instruction, and if we check for the logs, we can find that instruction now consists of way more advanced logic that we require for LLM to produce. So there is some text instructions instructing how to map one thing to another, and there are some examples that execute sort of the few shot learning scenario for LLM. So let's rerun our predictions again. Cool. So now, as we can see, the format, JSON format is different. And we can also even double check by uploading the data back to the Label Studio. So let's save our data in the file, and let's go and download this file so that we can now re-upload it back to our Label Studio. So here's our project where we expect to have the data to be appear. Let's go to the data manager. where we import the data. This is a blank project for now. I'm just going and upload this output data to our project. Importing it. And let's check. Okay, cool. Now we can see our data pre-annotated from the Hugging Face model. And we haven't implied any additional intermediate step of data transformation. So you can imagine that the pipeline can be seamlessly connected to the Adala inference, which is like run inference. And you can transform the data on the fly connected to the API, to any API, even beyond the Hugging Face. And you can see the results here. So the example I just shown is kind of tailored to what we actually experiencing and what we see the people experiencing with the Label Studio by connecting things together and by doing the conversion, which is sometimes takes most of the time of data ingestion pipeline to the Label Studio. But Adala actually can be extended way beyond this simple example, and you can imagine kind of text translation skills where instead of just converting one from one to another, you're translating the one text to another text. You can do the data labeling by means of classification, or you can do even like the sequence of the translation plus classifications. We have the available skills that you can check out and customize to your needs depending on different skills like the text generation, summarization, question answering. There is the tutorial that explains how the skill sets, how the compositional sequence of the skills can be combined together to make sure the agents can perform very complex reasoning tasks, and many other interesting scenarios that you can imagine with the agent. Okay, let's then maybe jump to the last slide of the demo. Yeah, just to quickly recap. So we just recently launched the Adala, and it's like still early stage open source project. However, we see a great potential, and we really appreciate your feedback, any sort of contribution from the like submitting the issues, stating out the project, or even submitting the code or extension to available skills, or like, for example, existing environments that you can connect to your particular channels. For example, I don't know, imagine that I want to use the Slack channel instead of Discord, or even like some channel where I expect that my annotator can produce the feedback based with the voice or with the other modalities. And so we believe that we strongly believe in the power of open source here. So we will not commercialize this platform, but instead our initial call is to from the community is to empower Adala with the different skills and different workflows, so that's it can grow based on the community effort, and that's essentially will give us ability to unlock the potential of AI, because we believe like AI should be based on the scale of the agent skills or agent abilities, and the idea of that agents, the more agents can be created in this ecosystem, the more powerful task you can start solving based on the data processing needs you may have, like which can include but not exclusively data labeling, data generation, and some analytical data stuff. So yeah, please join us in the community. Please help and extend Adala, and yeah, we will be more than happy to have you here in our Adala Discord channel, which you can find in the link of the repo.
Yeah, if you actually go to the next slide, we have a couple of QR codes that people can click through on.
Oh, sure.
That first QR code up there goes to the Human Signal Adala repository, and so this is all open source. You can check out tutorials, documentation. We also have a link to the Discord channel there. But the link below this too is also a QR code. That is an invitation to the Discord channel. If you have questions, if you have agents that you want to build, things, especially if you want to collaborate on a new agent, like I would love to see an agent that incorporates some of the combination of image labeling with text guidance. We would love to hear your ideas, and we'd love to help you build your own skills into Adala for your data labeling pipelines. And I want to say huge thanks to everyone for joining. And please, yeah, we can please feel free to ask any questions that you might have. We have Jeff Larson in the Q&A is asking, can the Adala bot in Slack Discord be programmed to screen some of their predictions before posting? For example, can it randomly sample 1% of the predictions, or can it only surface specific types of predictions? Did we lose Nikolai?
Sorry, can you repeat again? Yeah, I
Yeah.
would just.
Yeah, so is it possible to program the Discord or Slack connections so that it screens the information that it's actually sending? So, say that you want to do some sort of statistical sampling of results for an annotator to look at, like you only take 1%, random sample of 1% of predictions, or can you filter according to things like confidence intervals or other criteria?
Yeah, that's a great question. So essentially, yes, in a real world scenario, and even in this demo, you will not be requiring to annotate, and this is like the idea that's of automation, that you should not annotate everything you process, and of course that involves some particular sampling. Currently, we have like the random sampling in Adala that's sample, for example, as I just shown, one example from out of the data set consists of the 10 examples. In a real world case, you may have like millions of examples processed by your inference, and you want to just double check and review and provide the feedback for, say, like 10 examples or 100 examples in your channels, like Discord. And this would involve either uniform sampling as is currently implemented, or prediction confidence-based sampling to kind of serve for active learning-based scenario. Yeah, and so we can imagine might be more sophisticated sampling techniques that can be involved there, but I think most of the time, the uniform sampling and the active learning can be well adopted as the best practices here.
We have another question, which is also related to kind of this human interactive part of Adala that allows us to send messages for review. So could we, for example, use Telegram to review predictions by Adala? And the answer to that is yes. Adala has been designed to have to be a pluggable infrastructure, and so almost any piece that you see there supports connecting to an API. So as long as you have a Telegram API that you can send messages to, you should be able to customize exactly how Adala is sending requests to your review team for them to evaluate and send back. So right now we don't have a Telegram integration, but we would certainly welcome somebody developing one and contributing it to the project.
Yeah, absolutely. And like depending on exactly what might be the most popular channel that people would provide the feedback from, we'll definitely start looking into this direction.
We have another question, which is, will we be sharing a recording of this session? And yeah, so the Label Studio community has a YouTube channel. We'll be sharing the recording there. I've dropped a link to that in the chat, so you can feel free to go check out the YouTube channel right now. Yeah, and we'll be posting that once we have a chance to capture the video and edit it. We'll be posting it to the channel. Are there any other questions? Oh yeah, here we go. Grace is asking, from your demo, it seems that Adala is most applicable to LLMs. What about autonomous video modeling, such as, and computer vision for labeling?
Yeah, great question. So as you might know, OpenAI recently released the vision-based model API, which we will integrate very soon into Adala so that you can start considering the Adala as the computer vision agents as well. But the more the models, so essentially the Adala is data agnostic because it's the runtime. The idea of runtime means that you can just feed the data in whatever data type it is supported by runtime, and you can produce the output of the runtime that then can empower the skill, which essentially means that as soon as you have open source or enterprise multimodal models available for you, like for example GPT-4V or Lava model for the computer vision problems, you can seamlessly integrate that into Adala and use that as the environment that can drive your agent further. So the answer is yes, we expect to extend the Adala to many different modalities beyond the text, of course.
We have another question from Matt in the chat about, do you see Jupyter Notebook execution as the primary execution mode for agents, or do you envision service API-based scenarios as well? I can answer that, Nikolai, or you can answer it if you want.
Yeah, I can answer very shortly. It's even like in the roadmap to support the Adala server, where you can deploy the Adala and you can create the agents in this Adala server and communicate with them out of the box. But yeah, you can add something to that as well.
Vera is asking, obviously the primary usage of Adala is data labeling, but you mentioned other possible use cases too. Could you elaborate further on that?
So even the use case that I just shown you, so it's not exactly the data labeling per se in the classical sense. So which means that we generate some structured format that is not kind of the classical classification problem. But like if, for example, if we check the README, here we describe more similar to classical classification problem where you can given the text, you can classify the examples. But as I mentioned, you can envision the summarization or text generation skill, which I just shown to you. Moreover, you can think of the Adala that can analyze the data set, producing some meaningful context based on examples. And giving this context, you can derive some information from the data set. So it's sort of the data analytical operation that you can provide on top of your existing data that's based on the agent created information. You can find out specific data, or you can summarize it or aggregate it in a meaningful way. So that's what we call it, is like the Adala is a sort of the data labeling, but essentially it's the agents that allows you to perform data processing task where the main input is the structured data you see you feed into the Adala agent by means of the tables or by means of the just the table of the image URLs plus the some metadata information that might be useful for the agent.
We have another question from Yungwan. After training, will Adala produce the data conversion in a consistent way? If so, how do you do that? Is that part of the LLM prompt?
Yeah, it's a great question. So we use so-called constraint generation. That's you can like in case that you, for example, work with a free-form text generation skill, there is no any constraints involved on the output of the models. But for example, for the classification skills, you expect the model produce the output only for specific, like the output that's fit into some closed set of the labels, and which means that it should not produce anything beyond predefined set of labels, for example, positive, negative, and neutral. In order to do that, we are using the technique which is called constraint generation, where we basically constrain the model to produce only the target output based on specified set of labels or some particular templates that we expect the model will follow. And hence, we impose the structure on the output of the agents. So yeah, that can be actually even extended beyond just the labels. It can be, for example, the idea to fulfill some code placeholders and then execute this code. But yeah, if that's the answer to your question, I think the conversion is done primarily by this constraint generation engine.
Okay, that looks like that wraps up all the questions that we have.
I also found another question which we haven't covered, but I think it might be important because it's already asked by community. So the question is about the potential issues with open AI keys that you start using and you see the errors that is not used. So in this notebook, we will store the OpenAI API key, and that's something that you might want to get first time when you start experimenting and prototyping with Adala. The best way is to just get the OpenAI API key stored in your environment, so that the Adala can use this Open API key from the environmental variable and it will not struggle with anything else. So try to do this first. Try to use this OpenAI API key stored in environment with a Python code, or just exporting this environmental variable in your console. And yeah, just in any case you still encounter any problems, feel free to post it in the Adala Discord channel. We can help you with that.
Okay, everyone. I want to say thank you to everyone for joining us for this. We're really excited about the potential for agents, and I think that, especially seeing the OpenAI keynotes yesterday, where they announced agent extensions to the OpenAI platform. There's being able to extend the behavior of LLMs and kind of tap into that power in a way that is dynamic and gives you more oversight, we think is just such a powerful way to integrate both the kind of the power and the knowledge of these LLMs, and also really constrain the output with guided human feedback. We're super excited to have you join the community. I'm dropping another link here to the repository for Adala into the chat. Please go over, join the community. If you like the project, hit the star up there. It helps other people find the project and discover it and learn how it could help them out. Join the Discord community. We would love to collaborate with you on building new skills, new connectors to different platforms. And I want to extend my thanks for Michael for introducing us to Adala, and for Nikolai for giving us this demonstration today.